The ladder's 3.2 meters long, leans against a wall, makes an angle 61 degrees. Calculate how far up the wall the ladder reaches. I want to know this distance there. So I want, and I've got a right angle triangle, so this is going to be SOHCAHTOA. I don't use the sine rule or the cosine rule. This will just be standard trigonometry in a right angle triangle. So SOHCAHTOA. I know the angle, so I can tick S, C, and T. And what else do I know? I know the hypotenuse, I'll write that on there. And I want to find it's opposite the angle, so I want to find the opposite. And I just don't care about the adjacent. So the hypotenuse, I know that. The opposite is what I want to find. So I want this one. And so I always write down what I want to find first, that's the opposite. And S and H on the same level, that means they're multiplied. So it's sine, never write down the angle bit on its own, so sine at 61. Don't forget, if your calculator opens a bracket, you'll need to close the brackets, and then times by the hypotenuse 3.2. And I'll actually just typed it straight in to get 2.978783063, but you might want to do sine 61 0.874619707 times by 3.2, but anyhow, that's the answer. It says to a suitable degree of accuracy, and so what I would do there, the hypotenuse is given to one decimal place, so I would do the same here. So I'll do one decimal place. The next number is a 5 or bigger, so I need to round it up to from 2.9 to 3.0, and it's got the meters there already. And I'll say to what degree of accuracy I've given it, to one decimal place. I suppose you could have had, it would have been, if I know 2 decimal places, that would have been 2.97878. 2 decimal places would be like that. You would have rounded it up, so it would have been 2.98. But I think it's better in this case to give it there. Just check it makes sense. This opposite is less than the hypotenuse. That's good because the hypotenuse is the longer side. It's the one opposite the right angle. And that's question 3 done.